Hey everybody, Mr. Covey here, and today we're going to talk about how to solve rational equations. These are equations because they have an equal sign, okay? And there's really just two different types of rational equations we're going to solve. The first one is one that you definitely did in pre-algebra and algebra 1, and the second one is definitely something new, okay? So I'm going to kind of fly through this first type. I think you guys will be like, oh yeah, I remember that. The second type is tricky. So try and stick with it. The first type is fraction equals fraction. Okay, so it's called fraction equals fraction. And this is the first type because it's the easiest type. If you have a fraction equal to a fraction, and when I say fraction equals fraction, I mean a single fraction equal to a single fraction, this is not a bad equation to solve. I think that if you guys look at an equation like number 1 here, you remember last year, you're like, oh yeah, I know how to solve that. You do the little, you do that cross multiply. Okay. If it's just a single fraction equal to a single fraction, cross multiplying works. It's not too bad algebraically, and you guys can totally do it. Okay. The important thing about cross multiplying is kids remember, like, oh yeah, cross multiplying, like crisscross it like that and that. What they sometimes forget is that when you cross multiply, you still have an equation. Okay, like you're solving an equation. You still have an equation at the next line. So sometimes kids cross multiply and they drop the fact that we have an equation. Okay. Another thing to keep in mind when you multiply or when you cross multiply is if you want to do like 3 times 4x plus 5, it helps to put parentheses. Well, I'll rephrase that. You have to put parentheses or you're going to mess it up. Okay, because you have to distribute that 4 or that 3. Excuse me. And then when you do 9 times x plus 1, it probably helps to write the 9 out front. And then this is a linear equation that you guys know how to solve. Okay, no x squared. It's nothing weird. We're just going to distribute. Math, math, math. This is good old familiar, easy algebra. Subtract the 9x over, subtract 15 over. Boom, 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 boom. Okay. Now, one comment real quick. It is possible to get extraneous solutions. Extraneous solutions. You remember extraneous solutions from a few different types of equations we solved most recently, log equations. And so all you have to do is plug that back in. And all you're checking for is that it doesn't make the denominator 0. Any of the denominator 0. As long as it doesn't make a denominator 0, it works. So you plug -2 in. Doesn't make that denominator 0, doesn't make that denominator 0. It works, we keep it. If it did make a denominator 0, we'd throw it away. Okay. So another quick example of fraction equals fraction. Fraction equals fraction. We're going to cross multiply. Still going to be an equation. 1 times anything is just that thing. X times 2x plus 5, we need to distribute. So we get 2x squared plus 5x. Pause here for a second. Look at this equation. Uh-oh, we got a squared. It's going to be a little harder to solve. We got to make sure we adjust our mindset and say, oh, I'm going to have to move everything over and factor and all that stuff. But you guys know how to do that. So I'm going to move everything over to one side, subtract the 11x over, subtract the 8 over. I'm solving this equation. You guys know how to do this. You can do this. Take out a GCF. Now I'm going to try and factor. What multiplies to -4 and adds to -3? Well, that'd be -4 and +1. Remember, when you're solving an equation like this, that GCF of a 2 does absolutely nothing. My answers are x equals 4 and x equals -1. It's really important when you get 2 solutions to check if either of them are extraneous. Does 4 make either denominator 0 if you plug it in? Nope, it's good. Does -1 make either denominator 0 if you plug it in? Nope, it's good. They both work. We're good. Okay. You guys know how to cross multiply. I'm confident you guys can do that. Now, that is only a strategy if it's a single fraction equal to a single fraction. If you look at something like this, you're like, oh yeah, it's like fraction equal to fraction. No, this is a fraction plus a fraction equals a fraction. Anytime it's other than just a fraction equals fraction, we're going to use a different strategy, okay? This type is called more complicated. Oh, no. Okay. More complicated, oh, no, is important to be on the lookout for because you have a completely different strategy, okay? And the strategy is kind of weird. It's not cross multiplying. It's not anything you've seen before. What we're going to do is we're going to multiply. I'm going to call it multiply through by the least common denominator. Okay. So you remember least common denominators from when we did adding and subtracting fractions. Okay. And a lot of these equations, all of them are going to have adding or subtracting. And that's kind of the key. Oh, so it has to do with that least common denominator. So you're going to look at all the fractions, and you're on both sides, which is kind of weird. And you're going to find the least common denominator, and you're going to multiply the whole thing by that least common denominator. Okay. You'll see that it really makes it nice. Okay. Oh yeah, one thing I didn't say here. Sorry, this is my favorite thing. I say this. If you look at cross multiplying, all it does is take an equation and give you another equation. You're like, that's stupid. But it's actually really useful because the nice thing about the equation that cross multiplying gives you is that it doesn't have any fractions. So the whole point of cross multiplying isn't to like make it a different, or isn't to like solve it or anything. It's just to take it from being a difficult equation to being a simpler equation, an equation with fractions to an equation without fractions. Okay, and that's exactly what multiplying through by the least common denominator is going to do. So if you look at these three fractions and you look at those denominators, the least common denominator there is 4x. So we're going to take our equation and we're going to take every single term and we're going to multiply by 4x. Keep in mind when you multiply a fraction by something, you're multiplying the top by it. So we're going to do 4x there, 4x there, 4x there. Okay. So I'm going to get 20x over x plus 28x over 4x equals negative 36x over x. I'm going to multiply through by the least common denominator. Second thing you're going to have to do, I guess I should make a couple steps here. Simplify. The last step is going to be solve. Okay, simplify. Simplify these fractions. Cross out those x's. Here, 28x divided by 4x is going to be just 7 because the x's are going to cancel and the x. Here I'm going to have 20. I'm sorry, I made a little typo up here. My bad, let me fix that. That wasn't a 4x, that was just a 4. Silly Mr. Covey. Come on, Mr. Covey. Come on. All right, makes more sense. So I'm going to have 20 there, and here I'm going to get 7. I'm still going to have the x. There we go. Equals negative 36 because those x's are going to cancel. And now look, again, I still have an equation I got to solve. But what's nice about this equation? No, it just doesn't have any fractions. It's just a normal linear equation. Subtract the 20 over. I'm going to get negative 56 equals 7x. Divide both sides by 7. I'm going to get x equals negative 8. I do need to check this. It's really important with these ones too. Plug it back in. Does it make any of the denominators in the original equation 0? Nope. So it works. Let's do one more together here. I'm going to look at these problem. I'm going to say, uh-oh, more complicated. Oh, no. I have to multiply through by a least common denominator. I'm going to look at this denominator, and this denominator. I'm going to say, what is the least common denominator? Well, 2x times x plus 1. I need to have both of those in there. Okay, so I'm going to multiply everything, every single fraction, by 2x times x plus 1. And I'm going to take the second fraction. I'm going to multiply it by 2x times x plus 1. Again, it goes in the top because when you multiply a fraction by something, it goes in the top. And I'm going to take the last fraction and multiply it by 2x times x plus 1. Now I'm going to simplify. Those go away. What's 3x times 2x? 6x squared. Those go away. What's 5 times x plus 1? It's 5x plus 5, but I have to distribute that negative. So it's minus 5x minus 5. Those cancel. What's 3 times x plus 1? Keep in mind I got little parentheses there. It's 3x plus 3. Okay? This is about as hard as it gets right here, so stick with me. I multiplied through by the least common denominator. I simplified. Now I have to solve this, but again, you should look at this and be like, oh, that's a quadratic, so I got to be a little careful here. Okay? I'm going to move everything over to one side. Take out a GCF of 2. Maybe try and make my life easier. I'm going to factor. However you guys want to factor. I think a lot of you guys would do the split the middle thing. I'm going to do the guess and check thing, just because I'm trying to practice it like Mr. Covey told me to. I'm going to guess and check and see that that ends up working out. If you do the split the middle, you should get the same thing. Set each factor equal to 0, keeping in mind that 2 really doesn't do anything. I'm going to get x equals negative 2/3, and I'm going to get x equals 2 as my 2 solutions. I definitely need to go back, and I need to check these. Okay, x equals 2, doesn't make any denominator 0. X equals negative 2/3, doesn't make any denominator 0. I'm good. Check them both. They work. Cool. Flip to the next page. And I want you to give these 2 problems a try. Why don't you start with the first one? Pause the video, give the first one a try, unpause, I'll show you the answer. We'll go over it, and we'll do the same thing with the second one. Okay, guys, I hope you gave number 5 and 6 a try. If you haven't, please pause and do those. I'm going to go through those now. So for number 5, again, it's not a fraction equal to a fraction. It's a more complicated one. So I'm going to multiply through by the least common denominator, which is 3x. Okay, so I'm going to multiply through here by 3x. If you did 6x, that also works. It should work out the exact same way. I did 3x because it worked here, but if you multiply through by 6x, that's totally fine. I multiplied through, you would get a slightly different equation, but you get the same answer. I multiplied through by 3x. I ended up getting this, simplifying to this, solving, and got 4 as my answer. If you multiplied through instead by 6x, you would have gotten this equation, 4 plus x equals 8, and you would have still got x equals 4. Okay? Either way, you get the same answer. Don't forget to check if that works. It doesn't make any denominator 0, so it works. Okay? Number 6 was a little trickier. Here. It helps if you factor the denominator here to help you find the GCF. So I'm going to multiply through by x times x minus 3. That is my, I'm least common denominator. I keep saying GCF, the least common denominator. Okay, so I'm going to multiply by x times x minus 3. That's my least common denominator. I get right here. I do a bunch of simplifying. Those cross out, those cross out, those cross out. I'm left with this equation. This is a linear equation, nothing squared. I solve that linear equation. I get x equals 3. Now be careful here. If you go back up to the original equation, if you plug in 3, it makes this denominator and this denominator 0. Makes a denominator 0, meaning x equals 3 is an extraneous solution. It does not work. So what do you do with it? You cross it off. It doesn't work. So what are you left with? Well, you're left with nothing. And your answer is no solution. Okay. That concludes this solving rational equations video number 1.